friends, welcome back to Relay Tutorials. In the previous session, we have seen about different types of terms used in science or physics. That is what quantity is the property or characteristics of any substance which can be measured. Unit of physical quantity. The terms in which quantity can be measured is called as its unit: centimeter, meter, gram, kilogram, newton. We have seen some rules to follow while writing the unit also. Then we have started our chapter and we have decided that motion is a relative concept. It cannot be represented independently. To decide the motion of any object, first of all we have to decide the describing point or the reference. Let us see how the reference point or describing point affects the motion of an object. Also, we have seen in the previous lecture that there are two types of quantities: scalar quantity and vector quantity. Okay, now let us move further. Consider, here is one of the field. Here is pole A. Here is pole B. Here is pole C, and here is pole D. 4 lightning poles you can consider. The distance between each pole is 5 meter. So 5 meter between A to B, 5 meter between B to C, and also from C. So you can say the total length of the field is 15 meter. Let us say. Now here is one of the cow exactly between B and C. So this is the cow grazing some grass. Okay, so this is cow. Now two persons, Ritik and Akshay, are given one task. Both has to take the two observations of cow. Consider Ritik and Akshay. Ritik and Akshay both goes to the garden or the field at 8 a.m. So first observation both are taking at 8 a.m. Ritik stands here at pole A. So Ritik is using A as a reference point. A as his observation point, we can say. Akshay is standing at pole B. So Akshay is using B as his observation point. So at 8 a.m. according to Ritik, means according to pole A, the cow is at what distance away from Ritik? So I think this distance is 5 here and the cow is exactly between B and C. So this is 5 plus 2.5 is 7.5 meter. So at 8 a.m. the first observation taken by Ritik is that cow is at 7.5 meter away from pole A. But Akshay stands at pole B. So according to him, the cow is nearer. Cow is only 2.5 meter away from pole B. So look at the positions. Position of cow is different because both has used a different reference point, different observing point, different describing point. So it is very important that first of all you have to decide the observing or the reference point. Again let me describe. This is the field. Pole A, pole B, pole C and pole D, each having 5 meter distance between them. One of the cow is grazing between B and C. Ritik stands at pole A at 8 a.m. Akshay stands at pole B at 8 am. According to Ritik, cow is 7.5 meter away from A, and according to Akshay, it is only 2.5 meter away from B. Now, second observation taken. Now, both has been given the task that you have to take the observation after half an hour. Okay, so after half an hour, the cow is here at pole D, exactly under pole D. So again, Ritik came at time, and at 8:30 am, he has chosen his reference point as A. So again, he stands at pole A. Here is Ritik. Here is cow, the new position of cow. So at 8:30 am, what happens? According to Ritik, the cow is now 15 meter away. The cow is 15 meter away from A. Akshay was also given the task to take the second observation at 8:30 am, but anyhow Akshay was failed to reach on time, and Akshay reached at the garden or at the field at 8:45 am. And coincidentally, see, the cow is not directed by you. The cow is moving on the field according to its choice. So cow is moving here and there. At 8:30, at 8 am, it was here, cow was here. At 8:30, the cow was here. And coincidentally, at 8, this is the position of cow at 8 am. This is the position of cow at 8:30 am. And coincidentally, cow came back to the same point at 8:45. So when Akshay came to the field again he has taken B as his reference point. So again he stands under pole B, and he has taken the observation of cow. So the cow is still there. According to him, it is again 2.5 meter away from pole B. So both came to me by taking their observation. I have asked to Ritik. I have listened to me carefully. It's very important. I have asked to Ritik that what you have observed, is cow is changing its position between this half an hour? So what he will say, he has seen the two different positions of cow or not? He has seen two different positions of cow. So what Ritik will say, answer of Ritik. What Ritik will say, yes, cow is changing its position in the given interval of time. So in the given interval of time, according to Ritik, the position of cow has been changed. Now I have asked to Akshay that what you have observed, is cow is changing its position according to your observation. So what Akshay will feel, that at 8 am the cow was here, and at 8:45, because he has taken the observation at 8:45. So according to Akshay, at 8 am the cow was here, and at 8:45 am the cow was here at the same position. So he has seen the same position of cow. So what Akshay will answer me? No, the cow is not changing its position in this given interval of time. So according to Ritik, cow is moving. Okay, so cow is in motion. And according to Akshay, cow is stationary. So this is how the reference point affects, this is how the time intervals also has a relation with motion. When you observe, that is also important. From where you observe, that is already important. That already we have discussed. From where you are observing, that is important. And also when, means after what time interval you are observing, that is also important. For example, you yourself observe your father. Your father is leaving home at 9 am in the morning, going to factory or office, whatever. So what you will observe about your father at 8 a.m.? So he is at home. Okay, so at 8 a.m. you have observed your father that he is at home. Okay, now at 9 p.m. means at 9 p.m. at night, in evening. So what you will observe about your parents? For example, your father, maybe he is at home again. So position of your father at 8 a.m. is at home, and position of your father at 9 p.m. may be at home. So what does it mean? According to your observation, the position of your father is not changing. So your father is stationary. But we know that he is moving from home to office and office to home. But when you observe, that is also important. So when we can say the substance is in motion. So when the substance is changing its position, when the substance or object or living body or non-living body, whatever, when the substance is changing its position with reference to or with respect to reference point and with respect to the given interval of time, then only we can say the substance is in motion. If you observe that the substance at the same place according to your decided interval of time, the substance is stationary. You have to answer it that it is stationary. You know that your father is going to office at 8 a.m. So he is going from, we know that your father is leaving home at 9 a.m. But you have taken the observation at 8 a.m. and you have taken the observation at 9 p.m. So in both the time you have seen your father at home only. So you have to give the answer that your father is stationary according to science. In spite of knowing the fact, you have to give the answer. So that is the important thing in this chapter. That now let us see the definition of motion. When we can say the substance is in motion. So now the definition of motion comes here. Look at here. Listen to me. If an object under observation, just like the cow was under observation in the example, same way your father was under observation in the second example, same way whenever you are studying something. So if an object under observation is changing its position with respect to reference point or observer point or describing point, if an object under observation is changing its position with respect to reference point with respect to decided time interval or with respect to time. So if an object is changing its position with respect to reference point with respect to time, then the object is said to be in motion. Remember, you don't go for the facts. If you go for the facts, everything is moving in the universe. Whatever you observe is your answer. Okay, out of the syllabus, out of the record, you note one thing. What you means observer, what you observe is your answer in physics. Don't go for the facts. If you think about the facts, everything is in motion because earth is moving, so you are living on the earth. So if earth is moving, then also you are moving. Trees are moving, roads are moving, buildings are moving. In all the objects in the universe, each and everything is moving if you go for the fact. Don't go for the fact. What you observe is your answer. Is that clear? So what do you mean? What is the definition of motion? That if an object under observation, let me make it somewhat simple. An object under observation. So the long word I have used, lengthy. One typical word used in physics particularly, particle. When we think about the word particle, what do you mean by particle? So obviously you you assume that the small sized substance. No. In physics, particle means the object under study or object under observation. So object under study for motion is called as particle. Each and everything said to be particle. Even you are a particle according to physics. Even I am a particle under observation. For example, in that example, cow was under study. So cow is said to be particle. So what do you mean by particle? Particle in physics means the object under study of motion. In terms of chemistry, particle means the small sized substance of a matter. But here in physics, the object under study for motion is called as particle. Is that clear? Somewhat it's very complicated for me to explain you, but I have tried my best by giving many examples. We will study more examples to understand it clearly, but before that, now let's make some difference in the two objects. For example, one of the particle. Now I think you are getting the meaning of particle. Particle means the object under study. Consider this is particle A and this is particle B. A is in motion according to reference point and according to time. A is in motion and B is steady, means stationary, not moving. And what make it different? Lot of thing is different between these two. When the body is stationary, is it covering any distance? No. Is it covering any distance? No. Is it covering any displacement? No. Having some speed? No. Nothing is that. But when the substance is in motion, many characteristics are involved. Speed you can measure, distance covered by the object can be measured, time required to complete the motion can be measured, position is changing continuously. So lot of things can be measured. If I use the proper word in physics, the lot of quantities can be connected to the particle when it is in motion. Distance, displacement, speed, velocity, acceleration, and many other. So when the particle is in motion, many quantities can be associated. So now the topic, the core part of the chapter, that quantities associated to the particle in motion. So when the particle is in motion, many physical quantities can be connected to that. So let us study those quantities one by one. First important quantity to be studied is distance travelled. What do you mean by distance? Okay, consider here is your home and here is your class. Okay, this is your home and here is your class. One day you came to class by this route. Okay, let us say on Monday you have taken this route to come to class. Tuesday you have not taken the same route because there is always number of paths are available to reach the destination. You go to your friend's house first, pick up your friend and then came to class like this. So this is path followed by, this is the route you have followed on Monday, and this is the route or path followed by you. Path means the route, the road you have followed on Tuesday. The length of both the paths will be different. Let us say the path 1 having the length 2 km, and the length of the path followed by you on Tuesday is 3 km. Wednesday. On Wednesday, you are already late. So you didn't go to your friend's house and you have chosen the shortest path, the shortcut you have chosen, and go to class. So on Wednesday, this is the path followed by you. The rest of the length of this is 1 kilometer only. So now analyze this example that on 3 different days, you are going from home to class. So your starting point of motion and the end point of your motion is fixed. Okay, but on each day you are following the different route. So that is the point, that whatever the path you follow. So on the first day you have followed this path, so you have traveled 2 kilometers. On the second day you have traveled 3 kilometers. On the third day you have traveled only 1 kilometer. So distance means what? Distance means length of the path. Means these are the distances. So if someone asks you that what is the distance between your home and class, then which one is the correct answer? No one is the correct answer, because distance changes according to path. Distance between the two places changes according to path. Let us say on Thursday, 4th day. On Thursday, you go to class by the path followed. You go to your friend's house first, pick up your friends and go to class following the path you have followed on Tuesday. But when you reach the class, it is still 15 minutes left. You are reaching class at 15 minutes earlier time. So you and your friend decided that let us take some ride and go to eat some pani puri here. In reality, we have seen many students are going to eat pani puri just beside our class. So you have decided to go to eat pani puri, then have some soda, then have some snacks, and let us come back to the class at time. So if I draw separately, this is the path followed by you. Home to class to pani puri shop, then soda shop, and then come back to class. So this is your path. And let us say this distance is 5 km. So the distance traveled by you on Thursday is 5 km. On Wednesday it was only 1 km. On Tuesday it was 3 km. And on Monday it was 2 km. Since you are going from home to class only. But then also the distances are different, because distance does not depend on the place. Distance depends on the route you are following. So what do you mean by distance? Distance means it is nothing but the length. Distance means length of the path followed by moving particle. Length of the path followed by moving particle is known as distance traveled. So length of the path followed by moving particle is known as distance traveled. So distance means length of the path. Let us take some examples. Consider here, let us say here, Here is one of the straight road. This is bungalow number A, bungalow B, bungalow C, bungalow D and bungalow F. Distance between each bungalow is 10 meter. Okay, one of the person, let's say me, I myself starting my journey from this point A. Okay, I want to go to bungalow number C. Okay, so if I go like this, but in hurry, I passed away the bungalow number C and reached to bungalow number D. Then I realized that I reached somewhat ahead of the destination. So I take a U-turn and go back to bungalow number C. Okay, so the distance, if I ask you the distance traveled by me, so you have to see the path. You have to see the path. Otherwise, if you neglect the path, the distance between A and C seems to be 20 meter only. If I go straight away from A to C, it is only 20 meter, but I have taken the path like this. 10 here, 10 plus 10, 20 plus 10, 30 and plus 10, 40. So distance traveled by me is 40 meter. So distance means length of the path followed by moving particle. When you trying to decide distance, you just observe the path. So what are the units of distance? In which terms the distance is measured? Distance is measured in terms of meter, centimeter, kilometer, etc. One more thing to remember, distance is a scalar quantity. So when you describe distance, only the proper magnitude and unit is required, because obviously distance having no direction, look at this, distance having no direction to mention. So distance means length of the path followed by you or followed by moving particle. One more example and we will see one more quantity along with the example. Again you take the example of saying that this is your home and here is your classes. Okay, you have followed different types of path, 1, 2, 3 and 4 different types of paths you have followed on different days, but on each day you have displaced yourself by what? See, this is the straight distance between the two places. This is the straight distance between the two places. Might be there is no path available. There is not always a straight path available to go from one place to another, but that is not the matter of fact. The matter of fact is, on first day, for example, on Monday you have traveled 3 kilometer distance. On Tuesday you have traveled 2 kilometer distance, for example. On Wednesday you have traveled 1 kilometer distance only. But on each day you have displaced yourself by this straight distance. You were here initially at home and after all you reached to class only. So if you observe from the upper view or if you observe from air, you were here and you are here. So what is the displacement done by you? By what amount you get displaced from your place? That is important. So second quantity is displacement. Let us say the air distance or the straight distance between the two places is let us say it is 0.8 kilometer, for example, because it is the shortest one. Let us say the straight distance between the two places, home to class, is 0.8 kilometer. So if I ask you what is the distance, I am asking about the distance traveled by you on Monday, it is 3 kilometer because you have taken 3 kilometer path. On Tuesday you have taken the 2 kilometer path. On Thursday you have taken the 1 kilometer path. Okay, so distance is different because the paths are different, but in each case you are going from home to class only. So what is the displacement done by you on Monday? So your displacement on Monday is 0.8 kilometer. Your displacement on Tuesday is 0.8 kilometer. On Wednesday also, because your initial place and final place is same. So displacement is actually what? It is the straight distance between initial point and the final point of the journey. It describes that by what amount you get displaced from your original place. Okay, it describes by what amount you get displaced from your original place. If I say this is point A and here is point B, this is the path followed by one of the particle. Length of this path is 5 kilometer and the straight distance between these two is 2 kilometer. So the path followed is curved path. So if I ask you the two questions, what is the distance traveled and what is the displacement done? So distance means length of the path and that is 5 kilometer. And displacement is what? The straight distance between the two places. Whatever the path you followed, but actually you have displaced by 2 kilometer only from your original place. So that is 2 kilometer. So displacement actually described that by what amount you get displaced from your place. Is that clear? Let us take some more examples to understand the displacement. Let's the previous one. Look at here. In this, initially you were at what? Initially you were at bungalow number A. This is the initial point of your journey, and whatever the path you followed, but finally you came to which point? Finally you came to point C. So by how much amount you get displaced yourself? So I think that is 20 meter only. Distance is 40 meter. But here the state distance is 20 only. So in the same thing, your answer of displacement is 20 meter. Okay. Now let me try and think by yourself that if I say, for example, you reach at class and I am taking your lecture in classroom, and if I say you like this, that I reach here at class, analyze my statement, what I am saying. You are in the class now, okay, I am taking your lecture and I have told you that I reach here at class by covering 40 kilometer distance. Then what you will say? Oh, sir is coming from the very far place. No, is it like so? Is it so? No, I am talking about the distance. Distance means length of the path. Length of the path never describes the straight distance between the 2 points. If I say you like this in the classroom that I came here by covering 40 kilometer distance. So 40 kilometer distance can be covered by anyhow. For example, this is my home. Here is your home and here is my home. I go to this place and 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 then finally came to class. And in this covering all these I have traveled 40 kilometer distance. So is it so that I am coming from the very far place? Oh, this is not so. It is not so because distance can be covered anyhow, because distance means length of the path and length of the path can be increased by traveling on the same path again and again. We have seen many students here live here at class that most of the students came to class. If they are earlier, then what? Go to this place and this place and this place and this place and again then come to class. So wasting of petrol, wasting of time and increasing the distance. So eventually while going from home to class, may they have covered 20 kilometer distance. So it doesn't mean that they are coming from 20 kilometer distance. Distance never describes positions. Distance never describes from where you have started your journey. Distance never describes the actual straight distance between the two places. Never. So from distance you can never judge that from where the person is coming and from where the person has started its journey. Are you getting my point? Distance only describes the length of the path, and length of the path can be increased by many ways. You are traveling on the same path again and again to increase the distance. But yes, displacement describes the positions. So if I say you like this, that while coming from A to B, for example, this is B means class. So when I reach here, you are also here. And if I say you that I have traveled 2 kilometer displacement, so you came to know, the thought came to your mind that 2 kilometer displacement means 2 kilometer displacement means 2 kilometer straight distance away. So when I reach here, if I say I came here by covering 2 kilometer displacement means what? Either I am coming from 2 kilometer from this side or from this side or from this side or from this side or any side, means the straight distance I have taken. So my initial place of journey is straight distance 2 kilometer away from my final point. So now the confusion, for example, one more example to understand displacement clearly. Let us say this is our class. These are 4 different points. Place 1, place 2, place 3, place 4, all are 5 kilometers straight distance away from C. This place is in north, south, west, east. If I say you that this is my statement that I came here by covering 5 kilometer displacement. I came here at C by covering 5 kilometer displacement, then what you will take the meaning of this? Now 5 kilometer displacement means 5 kilometer away point, straight distance away point. So I think there are 4 different points are possible, point 1, point 2, point 3 and point 4. Then how can you decide that from where I am coming? I am coming from 1, I am coming from 2, coming from 3 or 4. But if I give the statement like this, that I came here by covering 5 kilometer displacement from south, then I think now you get the complete sense that I came to class from point number 3. So from these we can understood one thing, that displacement required value as well as direction for the complete sense. So displacement is a vector quantity. Distance having no direction, because distance means length of the path and path can be of any shape. So distance was the scalar quantity, but displacement is a length again, but displacement is a straight distance or the shortest distance. If I say like this, what should be the definition of displacement? Straight distance between initial point and final point of motion. Straight distance between initial point and final point of motion is known as displacement. Now displacement is a vector quantity because displacement required direction for the complete sense also. Let us take some example and try to derive another definition of displacement as well as another formula also. Consider here is the straight line. Here is point 0, 1, 2, 3, 4, 5, 6 and 7. The straight line society, for example, the distance between each one is 1 each, 1, 2, etc. means 1 meter, 1 meter, 1 meter, etc. So number itself suggests you the distance or displacement. You begin your journey from this point, from the gate. You have to go to bungalow number 3. First you go to straight distance bungalow number 5 and then come back to 3. Now in this case, what is the distance and displacement? So distance is, see, distance means length of the path. So it is 1, 2, 3, 4, 5, 6, 7. So distance traveled is 7 meter. But displacement means straight distance between the initial point and the final point. So what is your initial point? Initial point was 0. And what is your final point? Final point is 3. Okay. So final point is 3 and initial point is 0. So the straight distance is only 3 meter. So displacement is 3 meter. So here the displacement is 3 meter. Now how to find the displacement here? Can you see, look at here. Your final point is 3. In terms of physics, final point is represented as XF. X for position, F for final. The 0 is XI. I for initial, X for position. So this is initial position, this is final position. Okay, so what is your final position? 3. And what is your initial position? 0. So displacement, look at here, please carefully, we are deriving the formula. Displacement, can I say displacement is 3 minus 0 means 3? One more example. Let us say now you are at bungalow number 1 already. You are starting your journey from bungalow number 1. You have to go to bungalow number 3 again, but you go to bungalow number 6 first and then come to 3. Yes, yes. So I think bungalow number 1 is your initial position. Okay, so in this example, your initial position is bungalow number 1 and final position of yours is bungalow number 3. Now if I ask you what is the distance traveled by you, now distance means length of the path. So from here to here and then come back to this. So from this it is 1, 2, 3, 4, 5, 6, 7 and 8 meter distance traveled. But what is displacement? Displacement means straight distance between the 2 points. Okay, so what is their initial position? It is initial position is 1 and final position is 3. So you have to subtract final position minus initial position. So this is the formula for displacement for such type of examples only. The concept is same, the straight distance between the 2 points. So XF minus XI. So what is XF here? In this you have XF is 3 minus initial position is 1. So 2 meter is your displacement. One more example. Now you are at bungalow number 4 already. And you have to go to bungalow number 1. So you are going from 4 to 5 to 6 and then go to again 5 to 4 to 3 to 2 to 1. And this is your final point. So in this example, what is your initial point? In this example, initial point of yours is 4 and final point of your journey is 1. Now again you have to give the two answers, distance and displacement. Distance means length of the path. You just measure the length of the path. From here it is 1, 2, 3, 4. Look at this, these are the points are there. You are going from 4 to 5. So 1, then 2, then 3, then 4, then 5. So it is 1, 2, 3, 4, 5, 6, 7 meter distance you have covered. And displacement means we have a formula now. XF, look at here, xf minus xi. So what is xf? Look at these observations. Xf is 1 minus xi is 4. So your answer is minus 3 meter. So you will be surprised that why it is minus, because see, this was your initial point and this is your final point. So you are displacing yourself in this direction. In previous cases, you were displacing yourself in these directions. So this direction, according to this number line concept, this direction is positive and this direction is negative. So remember, this minus sign indicates the direction. In physics, negative number means negative direction. As I told you earlier, that displacement is a vector quantity, so it requires direction to mention. So here the negative sign is showing the direction. In the previous answers, the answers were positive for displacement, so this positive sign indicates the direction. So in physics, positive and negative signs only indicates the direction of motion. Is that clear? In the next session, we are going to solve many examples to find distance and displacement to make your concept clear. Till then, you just make the notes, definitions and important points to be written in your book. Please follow this. Please, it's a very important base of your motion, because once you get we have chapter like motion, then we have chapter number 9, force and laws of motion, then chapter number 10, gravitation, then chapter number 11, work, energy. Chapter number 12 already we have done, and that is of sound. Okay, so these are the part of physics, but these four chapters are associated with each other. Motion is the base. Once you go through the motion, if you understand the concept of motion very well, then only you go for force. Otherwise, force couldn't be understood. Then gravitation also can be understood when you go for the force. So these are the link between the motion, force and gravitation. So please, this is the base of motion. Still many things to cover in this chapter. Best of luck.